Here we've got a nice algebraic division problem. This is part of our just standard algebraic techniques. It's just mucking about with symbols, which is really fun. Literally just like Play-Doh, like making things like Play-Doh, just moving them and making them look different, and it's fun. So we've got that, and then we've also got, as well as the algebraic division in part B, we've got the equation of the normal. So what do we need to write down here? What do we need to make notice of? Find A and B, hence using calculus, find the equation of the normal. I think we should probably underline the normal and make a note to self, not the tangent, at the point where x is 3. I think that's the most important thing there. It's not the tangent. And, oh yeah, I remember what I was going to say about this one. So this is just like a tip, but basically, lots of students, they got in a tangle on A and then they couldn't do B. But that's not actually true, because look what B is saying, hence or otherwise. So just forget the hence a minute. Find an equation of the normal. How do we find the equation of a normal to a curve? 1, we differentiate it. Okay, do we know the curve equation? F of x, yes we do. We don't know it written in a more simplistic form because we screwed up part A, but whatever, we do actually know the curve. So we could differentiate the curve using the original thing and not using this thing if we couldn't find it. So we differentiate the curve, sub in x is 3 to get the gradient of the tangent. Then we're going to flip that upside down and do the negative reciprocal to get the gradient of the normal. And then we are going to sub all that, the gradient and the point, into the line equation. Would we have the point? We've got x is 3, we don't know what y is. So we'd need to actually go and find out what y was. Y and f of x are the same thing. So we can sub 3 into either this form or this form to get the y coordinate. And then that point together with the gradient that we got here makes the equation of the normal. And notice they haven't actually said giving your answer in the form. Blah, 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 find the equation of the normal to the curve at the point. So we don't have to do any rearranging here. Which is good. We can literally just stop at this point here. Right, what about that first one? What's that asking us to do? We've got a top-heavy fraction. There's a 4 there and only a 2 on the bottom. So this has got twice as much power on the top as in the bottom, which means that we can kind of pull off all the bits that make it heavier on the top and give us something that isn't heavier on the top. So we pull off all of the bulk off the top of the fraction using algebraic division. And then that leaves us with a quotient, x squared plus a, and a remainder. And this is the important bit. The remainder is still on top of, well, something weird's happened here. Look, the denominator's changed. We'll have to come back to that. But the remainder is still on top of the original denominator. I'm going to put question mark, because somehow that original denominator, x squared plus x minus 6, has changed to x minus 2. So we'll have to see what's going on with that. But I think that's enough to get us going. I think we know what we're going to do, so let's try it.